dry oxidation. Okay, so topic wise I will tell from here. Wet oxidation, dry oxidation. You can note down a question. All questions you prepare at least for 4 marks answer. Okay, 4 marks answer. Then thermal oxidation process. Thermal oxidation process. Then what are the steps in photolithography? What are the steps in photolithography? Then what are the different photoresist that can be used? I can show you in the PPT, but it will take more time. You can note down in simple. Based on that, you can prepare answer for 4 to 5 marks. Each question answer for 4 to 5 marks. Preferably with diagrams, with equations, you will get full marks, both in internal as well as final exam. If you write equations, it is excellent. 1 or 2 equations compulsory for every topic. If equations are there in the PPT, you learn and write. Okay. Then coming to the projection systems, you can see optical projection is there, proximity projection system, okay, contact projection system. What are the different types of projection systems with possible diagrams? Everywhere with possible diagrams we have mentioned in the question paper, so diagrams are expected. Without diagrams, if you simply write 4 lines theory, you will not get marks. Okay, everywhere in the question itself we mentioned with the necessary diagrams, so you have to draw diagrams. Diagrams are easy to learn, okay, rather than theory. Lot of theory, diagrams once or twice you remember. Next, X-ray lithography. Next question, electron beam lithography. Some 4-5 questions I told you. Pre-cleaning, okay, pre-cleaning of oxidation. First question, pre-cleaning of oxidation. Next, here I didn't tell any question. Then thermal oxidation process. Then what are the steps in photolithography? What are the photoresist materials used? What are the types of, okay, the exposure systems? Okay, proximity, contact and projection. Next, steppers, you just leave it, it is a small topic. Then X-ray lithography, 1 question. Electron beam lithography, another question. This is about 3rd unit. 4th unit, etching. Difference between dry etching and wet etching. Okay, difference between dry etching, wet etching. Then dry chemical etching is there. Okay, physical etching and dry chemical etching. Okay, wet physical, dry chemical. Those classifications are there in the PPT. You just go through it. Then what is plasma etching? 3 questions I told you here. One is difference between wet etching, dry etching. Second one, wet physical etching, dry chemical etching. Okay, with the diagrams or equations. Next, next is plasma etching. Okay, plasma etching. Next, ion implantation. Here range and penetration. Okay, so here no need of any question here. Ion implantation, what are the advantages, disadvantages, applications? What are the advantages, disadvantages, applications of ion implantation? Then what is annealing process with equations, diagrams? What is annealing process with what is annealing process with diagrams and equations? Okay. Then diffusion. So you have something called, here some equations will come. Constant and infinite source diffusions with equations. Constant and infinite source, interstitial diffusion is there. Diffusivity is there. Okay. So diffusion profiles means you have some equations and graphs. Okay. So all those things you study here. And the last question in 5th unit, PVD. Physical vapor deposition. 2 methods are there, thermal evaporation and sputtering, with the diagrams and necessary equations. Okay, so I have told you in 4th unit, wet dry etching, wet physical and dry chemical etching, and then here annealing process with the diagram equations, ion implantation, different types, then advantage, disadvantage, applications. Then coming to diffusion, what are the equations and diagram for constant and infinite source diffusion. Then you have some graphs also, diffusivity, interstitial diffusion. Okay, all these things. And in the 5th unit, PVD, physical vapor deposition. What are the types with necessary diagrams and equations? Okay, so with this I will close here. I will get a